Friends, today in PK Technical Classes, you are most welcome. Today we are going to design half adder using Nand Gate. So this is the block diagram of an adder, half adder, and we are providing two inputs A and B consecutively, and we are getting the outputs sum and carry consecutively. So we can see the diagram of truth table, like when A and B are provided 0 0, sum and carry are 0 0, but when A is 0, B is 1, sum is 1 but carry is 0. Again A is 1, B is 0, then sum is 1, carry is 0, but when A and B both are 1 1, at that time sum is 0 but carry is 1. So implementing it in the get logic, we can see that sum is equal to a dash b plus a b dash, and carry is equal to a dot b. And if we want to change this logic gate diagram into NAND logic, you can see that these type of structures can be seen. So these are the transistors in which A and B are the inputs and Y is the output. So let us see, we have to design this structure, and how we can design this structure or not, we are capable of designing this structure or not. So let us see, we will try to design it in our software Microwind 3.8 version. So let us see. So first of all, what we will do, we will take one gate, and after that we'll copy and paste it so that more number of gates could be created, and let us see how the design could be created. Okay, so make it zoom out so that we can make it a good design. So first of all, we have to take the P diffusion structure. I have taken the P diffusion structure over here, and we have mentioned this P diffusion like this, and after this P diffusion we have to take the N diffusion also. So how can we take the N diffusion? We can see, taken the P diffusion over here, and then we are taking N diffusion. So we are taking N diffusion over here, we are taking the N diffusion likewise. So let us see that the design structures can also be manipulated several of times. If there is any defect or any problem can be seen in the design structure, you can just implement it, or you can also able to change it. So let us see what happens. So likewise, we have taken the P structure and N structure, and then what we have to do, we have to put our metal contacts. In P type we will put P diffusion. For P diffusion we will put P metal contact over here. 3 metal contacts we are going to put. For N diffusion we are going to put N metal contacts over here. After this structure, I have to take the metal gate, and if I am going to take the metal gate, I can draw the structure likewise according to our requirement. So we have made this metal gate over here, and then actually we are making the NAND gate. So after that we'll make the combinations of NAND gate, and we will connect the different type of connections. So just right now I'm making the connections over here. Then we have to take the polysilicon structure, MOS gate as a polysilicon, so this is the metal gate structure I have taken. And if I want, then I can also able to delete some of it portion if I don't need those portions. Okay, so first of all, see that what are the structure has been created. Then I will decide to take the anvil over here likewise, and after this anvil I will connect VDD over here, and again I will take one more VDD over here, and then I will take ground connections over here, and for the input side I will decide it later, or also I can make it now also, but I wish to take it later. So this is my design for a single NAND gate, and the connection is been completed. So can take over here so that it will be appropriate, and I have taken the VDD, so I can take the VDD over here also. If I want, then I can take according to my choice. VDD can be taken over here, and then what I have to do, I have to just copy paste it. So for being copy paste, I have to just select it, and then I will make it copy paste. So first of all I will take the metal contact for this portion, and again for metal contact for this portion also likewise, and I think that I have completed the structure. And then what I will do, I will take the copy paste the structures likewise. We'll take one. I will just have to make it more small so that I can maintain the structures. again I have to do this. Again I will take the structure likewise, and then I will take it, and when I will make the structure I will take the appropriate diagram for this, and the diagram would be of likewise order. So again I have to take it because I have a lot of structures are in there, so sometimes selections becomes like this. So I can take it over here, or here also I can take it, just put it over here if there is no any more means difficulty, and according to your choice you can do it. And for this operations you can put it likewise. So take these diagrams as you wish according to your perception. So just make it over here likewise. So taking these structures likewise, and then what you will do, and have to connect it as its requirement. Again we have to connect the gates structure according to its requirement likewise. So this is the structure and you have to connect it likewise. This is the connection, and whenever we want to make the proper structure to align it likewise, I will take a metal gate over here, and up to a certain width I will take likewise. Take the metal gate over here. So after taking the metal gate structure likewise, then we have to connect the some of the portions likewise, as I have to connect metal gate, or I will take polysilicon and I will connect this gate with this structure of metal gate. Then again I will do the same procedure, and after that also I will take the same procedure, and when I have made this gate structure, I will put this contact metal of polysilicon these points for connecting or connections. I can say that will be appropriate connections, as we can see. So after this I have to do that the structure is still to make it some alignment from this position. So I have to take the metal one over here, and I will take metal gate likewise, and I will take it to this position. I will take it to this position. So for appropriate structure I have to do it. So I have taken the metal gate over here, and after taking the metal gate I will have to connect it with polysilicon, or where I can see this is a type of MOS gate over here. So I have to take the contact likewise, and then what I have to do, I have to just take the metal one, and then I have to connect this metal one with the gate of this structure with a contact likewise. So now the structure can be said as properly I have connected, and I will verify it. This MOS gates must be connected, and then what I have to do, I have to take two signals. One first clock signal, which is I will take as clock 1. I will take clock 1, and the next I will take as clock 2 over here, clock 2, and assign it. First I have to take clock 1, then I have to take clock 2, just assign those things, and after assigning what we can do, we will take the carry portion. So for taking the carry portion, what I have to do, I have to take the output portion, and I can align it here over. So I will write it carry. And I will take the sum over here. I will take the sum over here. So this is my sum. So let us see that for this half adder circuit I have connected two clock signals as input, or I can take clock 1 and clock 2, and this is the carry part and this is the sum part. So while making this structure, I've done a lot of connections over here, as you can see in the screen. And after this making this structure, I will stimulate this diagram, so I can see different portion of clocks, and clock 1, clock 2, carry and sum. These portions we can see over here likewise. So this is 100 nanoscale of timing. Even if I will make 10 nanoscale of timing, I can get likewise. So these are the structures I can get. And for 50 nanoscale timings, I'll get such type of structures. You can see, so for different type of scalings, whenever you go for different type of scaling, different type of structures can be result at the output portion. You can observe. So this is the voltage versus time graph plotted in at the output portion, as you can see. And after this, if you want to see the voltage to current graph, you can see the voltage to current graph is likewise for this half adder circuit, which is implementation of Nand Gate implementation. So this is the axis of our milliampere axis, and this is the axis of our time axis. So this is the VDD supply, which I have given 1.20 VDD supply. The volt in the y-axis is the current. So this is the plot for voltage to current plot. We can see. So voltage versus voltage plot can be seen over here likewise. Frequency versus time plot, if we want to see, so this is the frequency portion within gigahertz, and this is the time scaling. So frequency versus time, we can see the plot of this graph. After this, the eye diagram, we can also able to see the eye diagram. So these are the structures we can see. After this, we will go for what we have connected. So initially substrate we have taken. After the substrate we have taken AND diffusion. After that SiO2 trench isolation, then thin oxide growth, thin oxide reduction for polysilicon deposit, N plus implant, P plus implant, embedded DRAM, second polysilicon deposit, create contact, metal deposit and etch via hole and fill, metal 2 deposit and etch via 2 hole and fill, metal 3 deposit and etch via 3 hole and fill, metal 4 deposit and etch via 4 hole and fill, metal 5 deposit and etch via 5 hole and fill, MEM dielectric, metal 6 deposit and etch, passivation oxide deposit, passivation etching and the end of this process. So this is the whole diagram which we can see. This is the 3D view we can make of this package. Okay, and if we go for a different type of selections, automatic selections can be also participated likewise, as I don't have to go for clicking each and every part, and we can observe each and every part how is made and the process can be viewed. Okay, then we will go for the 3D plot. How the 3D plots is, you can see the 3D plot. So this is the 3D plot. You can see the 3D plot over here. We can make smaller or larger this pattern. So this is the 3D plot. We can observe that how this 3D plots has been done automatically. You can see, observe that the different type layers and different type of things has been made and connected over here likewise. So these are the patterns of making of this half adder using Nand gate with transistors like MOS. So I hope you will like this video, and thank you for subscription of this videos, and thank for observing these videos. Thank you at all. And if there is any type of circuit diagram which you need by this help of VLSI design, or any type of circuit diagram which you want to see by the stimulation, just write it in the comment and we'll work for it. Thank you for today in this PK technical classes.